Yes. All right, welcome back, everybody. Yes, this is the important garb. So it happened once where I wore this to class after a game that we won, and we won this game. So if the Seahawks win again, I'm going to be wearing this on Monday. But either way, very, very important before we even get started with some review and stuff. I highly recommend this at your next Thanksgiving gathering. It is a very, very tasty dish, very easy to make. Um, and very, very editable, which is very nice for Thanksgiving if you're the person who's cooking Thanksgiving because there's a lot of variables going on in your household and it becomes very difficult to keep everything on track. But this thing is like you can do whatever you want and it'll probably work out fine. I say at 350 degrees, you could probably put it at 400 to be fine. You could put it at 375, it'd probably be fine. 30 to 60 minutes, just depending on your desired thick, like doneness. Um, but it literally can like lower oven, more time, higher oven, less time, the whole deal. Highly recommend it. You think it wouldn't be good, but it's actually very, very delicious, and it's a great Thanksgiving side dish. So, anyways, um, now on to actual stuff, which would be just a review. So we've gone over everything in the course, at least everything that is required of the course, and especially considering that this is as I told you guys, and I'm telling this not just for my class, and I'm saying it again. I know I'm sounding like a broken record, but I wanted to stick in your head that Thanksgiving is the kiss of death for every fall semester. It is the kiss of death, and I don't want you guys to fall susceptible to it. Yes, you guys are going to be on break for about 5 days, and it's going to feel tempting to slow down your marathon. And I want you to enjoy your Thanksgiving as much as possible. Have some great conversations, have some heated debates, that type of stuff, things that make life worth living. But you need to stay focused because we're going to come back. We're going to only have 1 week of class left, and then you'll have finals week. So that's kind of another reason why I've decided to have our last exam next week, so that you put your nose to the grindstone, at least in this class. Maybe your other classes fall behind. I don't care. I do care. I want you to pass all your classes. But this kind of just forces you to stay a little bit focused, at least spend them some time on Saturday, like maybe Friday, Saturday, and Sunday. Easy chance to get away from people. Say, actually, I need to go study some math. If you prefer not to get into a heated debate, whatever it may be. Um, that's just it's another cautionary reminder about fall semester and the kiss of death that is Thanksgiving. So, as a reminder of what's to come this week, technically speaking, we do have class on Wednesday. However, I am not going to be expecting anybody to be here. I would like you guys to be spending that time relaxing and with family. I know there's a lot to get done right before Thanksgiving, so please spend that time enjoying yourself. But if you want to come to class, I'll have more review that day. Um, then next week we have our fourth exam. Pretty standard, just like everyone else. Every of the last three. There's a formula sheet. All the formulas that are necessary will be provided. And then on Wednesday we have our final quiz. It's just an assessment quiz. It's I think 10 questions if memory serves. It is all multiple choice, but I will also be grading it for partial credit. So if you get it wrong, but you show some work, you're entitled to probably a fourth to half a credit. Um, and then what else? The final quiz is cumulative, so it covers all material from the course from from unit 1 to unit 4. Um, and but the exam coming up on Monday is just on. So I can even write this down for you guys. Exam 4 covers 4.2, 4.3, and 4.5. So that's the fundamental counting principle and permutations combinations. That's 4.2. 4.3 was basic probability and odds. And then 4.5 was expected value and fair price. So this one's a pretty short exam. So that's the good news. And then the final quiz, cumulative. Now, the good news with cumulative exams, at least in my opinion, is that a cumulative exam should not incorporate, at least the way I design my final exams, is that a final exam should not be to try and test you, like to push your boundaries on knowledge, which our exams are for. Exams usually have like very niche questions to enhance learning, but a final exam is supposed to be for, did you learn anything from the course? I don't need you, like, did you learn the core concepts? I don't need to be asking you the very, very niche questions. So the cumulative exam, the cumulative quiz, excuse me, will just be like overarching questions from each unit. Things like, can you use the Pythagorean theorem? Can you use permutations and combinations correctly? Can you find probability? Not some weird niche topic. But the exam will cover those things because it is a isolated exam. Any questions on that? The overall structure for the next 2 weeks? Yes. Oh. Yes. So absolutely. On the yes, I have there's a cheat sheet on the back of it, and it has a sum of all rolls for six-sided die, two six-sided die. So it has like all the different results. It also has a visual aid along with all the breakdown of information for decks of cards, so you don't have to have that memorized. It has the expected value formula. It has permutations and combinations, though our calculators always have that. So please make sure, speaking of which, that you know how to press that button in your calculator, where you can find the combinations button, where you can find the permutations button, because that will be important. I mean, it's no surprise, right? That was one of the 3 sections that's on here. But you can use the formula, and writing down the formula, even if you don't know where to calculate it, writing down the formula is usually worth about half the credit on those types of problems. So as long as you wrote, like if it's 15p6, if you write that, even if you get the wrong answer, writing 15p6 will get you about half the credit. Are there any other formulas on there? Oh, the not formula, but there is the the definition of odds in favor and odds against. Right, odds in favor is chances of successes to chances of failures, whereas odds against is chances of failures chances of successes. Those formulas are quote unquote formulas are provided, and I think that's everything. Any other questions? Last 2 weeks. All right. Then the last week, which is finals week, we do not have class. As soon as you take the final quiz and you turn that in, you're all done with my class, and you go on your merry way into a great holiday break. Not really, because you still need to take your other exams, but we don't have a final exam schedule here at CSN, and I've seen the arguments why, but that kind of puts you guys at a very disadvantage, because then you have like 3 exams on Monday and 3 exams on Tuesday typically. So if I can alleviate that where possible, I will. So that's what I'm going to be doing. I'm going to be trying to give you guys, especially since this class doesn't really need a final exam. So anyways, I'm rambling. Let's go ahead and do some review then. So one last thing, now that I think about it, because I'm thinking of problems to do. Please remember, with permutations and combinations, I will be using those keywords on problems. So if you see order, so let's even write that down. Permutations, order matters, and the keywords are things like order, arrange, order and arrange are the typical, like any word that is synonymous with order or arrangement, those are going to be permutation problems. With combination problems, order does not matter. And the keywords to look out for here are things like select, choice, or choose, pick, any words that are synonymous with that where there's no implied order. You can select anything from a list, right? You can choose anything from a list, from a menu or whatever. You can pick any item from a menu. There's no specific order that it has to be done in. So those are the keywords to be looking out for. Hopefully, there's enough contextual clues to make you determine whether or not order matters. But if not, then look for those keywords. So, does anybody have anything they want to go over in particular? I'm happy going over whatever. Unit conversions, those won't be covered on the exam. They'll be covered on the final exam. But I'm happy to go over one. I'd like to wait until like any unit 4 questions first, but then I'll do that. Yes. I can pull them up, yes. Sure. 4.5, you said? Okay. Uh, Give me one moment. Let me pause the recording. That way we're not just recording. Okay, so one of the questions that students wanted to ask was question 9, and question 10, I believe, is very, very similar. Yeah. It's the basically the same question, but just with the different with a different image. With a grandma versus a young, successful woman. So, according to the tables used by insurance companies, a 73-year-old woman has a 0.289% chance of passing away during the coming year. An insurance company charges $217 for a life insurance policy that pays $100,000 death benefit. What is the expected value for the person buying the insurance? Okay, so I'm going to pause the video so I can switch back over. Share. Wait, it's supposed to go there. And then there we go. All right. So resume the recording. Okay, never mind. I forgot to pause it. Oopsies. Well, we're having a fun time. Anyways, okay, so question 9. Question 9, homework 4.5. I think it said, so like I can't look back at it at the moment, but I think it said a 2.89 or a 0.289% chance of dead. And in that case, you get $100,000, and it's a $217 policy. So it's a 2.89% chance that they're going to die in the next year. And if they die, then there's a payout of $100,000. It's a $217 policy. What is the expected value? So there's 2 outcomes of the following year, right? Either she lives, yay, or she dies. Dark, but whatever. So we could either make our chart if we'd like to, or you can just go ahead and straight go into the expected value formula. I'm going to do it the long way. So the outcome, the probability, and then the net result. So either grandma's going to be home for Christmas or she's not. Lives or dies. Dark, but yes. I mean, when you're working in insurance, you kind of have to be. So the probability that she lives would be 100% minus that 0.289% that doesn't work. So let's see here. 100% minus 0.289 is 99.721. 711, excuse me. So it's a 99.711% chance that she lives and a 0.289% that she dies. Now, if she lives, she does not get the payout. Sad day. She didn't get that $100,000. I mean, give or take. So she'd be out 217. But if she dies, then she's going to have $100,000 going to her family minus the $270 that she had to pay for the policy, which so 100,000 minus 217 is 99,783. Yeah. So the expected value is the probability times the results of each thing added all together. And so key thing though, remember, whenever we're working with percentages in formulas, we want them to be in decimal form. So, and the other thing to remember is that probability really is a percent chance. And when you have 1/2, when your probability is 1/2, that's a 0.5. If you plug it in your calculator and write it as a decimal, it's 0.5, which means it's a 50% chance. So in the same fashion, we can go in the backwards direction. The expected value here would be 0.99711 times negative 217 plus 0.00289. That's the weird one, but because it's a decimal percentage, moving it 2 units to the left, right? Not left, correct is what I should say, like right there, gives you 0.00289 times 99,783. And if we plug that into our calculator, should get so 0.99711 times negative 217 plus 0.00289 times 99,783. I get 72. Does everyone else get 72? Okay. So this is a good expected value. We're hoping for I can't make that joke. That's too dark. But that's a good expected value, right? That's a positive number that's working in your favor, not in the insurance company's favor, but then again, screw them, right? So the other one is done very, very similarly. I think it's basically the only difference is the numbers and the prompt of who the life insurance policy is on. But a good example of a expected value problem. Any other concepts from Unit 4 that we'd like to go over? Can't think of one at the moment. If so, I was thinking of just going over kind of one of each, and then we can go over to Lisa's question about unit conversions, or we can throw one in the mix. So let's go ahead and do some examples. Let's see here. What was it? Mondo Burger. Is that the name of it from Good Burger? Does anyone remember? Did anybody watch Good Burger? So way before your time, I'm pretty sure. It's a movie with Kenan and Kel from all of that, back when they were known for all of that instead of anything else. But it's an evil corporation in that movie. Has 3 different LBS burger patties. Let's say 10 different burger toppings. Let's say 4 different buns. And 8 different sauces at their create your own burger station. How many uh how many choices are there? Sorry, how many different options? If you can choose up to 3 toppings. Sorry, those problems take a long time to write. Apologies about that. Wanda Burger has 3 different pound burger patties, 10 different burger toppings, 4 different burger buns. They got the classic, they got the brioche, they got the wheat, and then they've got the ever coveted the pretzel bun, which everyone knows is the best. And then 8 different sauces, and assume you can only have 3 toppings and 1 sauce. I'm assuming we wouldn't want to, like, it makes sense. You don't want to mix sauces, right? You don't want to have ranch and teriyaki sauce. That sounds good. That sounds grody. So I'm saying you can choose up to 3 toppings. That way, we'll see in a second. So this is a fundamental counting principle problem. This isn't a permutation. This isn't a combination because there's not like a shared element amongst the things. That like a permutation or a combination is n objects chosen r at a time. They have to be all the same types of objects. So this is wildly different objects. And we're assuming that each burger, that create your own burger, is just 1 patty, 3 toppings, 1 bun, 1 sauce, right? And so this one, honestly, this is where we could get like, there are many different things that could throw this question for a loop, and I'd be accepting of any of them because like you could also choose to not have any toppings, right? So technically speaking, there's 11 different burger topping options, and that's where things get a little bit gray. And if this is in and out, you can also do the whole thing where there's also a new type of bun. You could also just do lettuce. But either way, let's just assume that we're going to choose one of everything but 3 toppings. So solution. Fundamental counting principle says that you take each event in the multi-part event and multiplying their options together. So 3 different burger patty options times 10 different burger toppings, but you can pick up to 3. So like I would accept either writing 10 or 11, depending on how you viewed the question. If you viewed it as saying you could choose up to 3 different burger toppings, but you don't have to choose, then that would give you 11 different options. But I'm going to assume that you have to pick one. So we're going to assume like this is also another thing where it's gray. Is could you just ask for 3 times? Like I want onions, onions, onions on the burger, right? Does that count? And my answer is no. So each one needs to be an individual choice. So 10 for the first topping, then 9 for the second option, then 8 for the third option. Does that make sense? Technically speaking, though, if we did allow, like, if this was the question, I'd be far more specific about the verbiage. I just was creating this up on the spot. However, if this was the verbiage and you decided to do 10 times 10 times 10, I would give you full credit. So 3 times 10 times 9 times 8, that's all the different toppings. There's 4 different buns, times 4 different buns, and then times 8 different sauces, and assuming you can only choose 1 sauce. And so if we plug that into our calculator, 3 times 10 times 9 times 8, 3 times 10 times 9 times 8 times 4 times 8, 69,120 options. So quite a few burger choices. Yes. Yes, exactly right. Yes, excellent question. So Odlis was saying, is the reason for the 9 and the 8 because once you've picked a topping, you can't pick the same topping again. And the answer is yes. Once you chosen lettuce, that's no longer in the choice pool, so that reduces the number of options by 1. Kind of like when you're doing like one of those problems with the secret codes, right? Where it's like 5 letters and 2 numbers. And if you don't allow repetition, then you lose a number or you lose a letter each time, right? So, any other questions on this one? Okay, let's do another example. Let's say your DVD collection, because this is the 90s, you see, your DVD collection is 40 strong. You got a bunch of DVDs. You got 40 of them right now. But your shelf only holds 10. I don't know why. It's a weird shelf. Maybe you only have like you got all the other things. You got your other video games. You got your Nintendo 64 video games. Whatever it may be. How many different ways can the 10 be ordered? So this is a choosing of n objects because they're all the same thing. They're all DVDs. And so you're taking 40 of them and you're choosing 10 at a time. But the question is, you're ordering them 10 at a time. Is this permutation or a combination? Permutation because of the term ordered. I would think personally that these problems, it wouldn't really matter which 10 you picked. However, because it used that word ordered, it matters. If you put Lord of the Rings, if you put The Hobbit after the Lord of the Rings, it doesn't make as much sense, right? So, solution is this is a permutation, and it's 40 choose 10. So it's 40p10. And if you plug that into your calculator, it's going to be a very, very large number, but yeah, it's going to be a very, very large number. It's going to give it to you in scientific notation. It's going to be 3.0776 times 10 to the 15th power. Very, very large number. That's 15 digits after the 3. That's how big that number is. Total aside, just because I'm curious, would scientific notation be something that you'd rather see in this course, or do you not care? Exactly. That's so like it's not a it's a very, very rare thing. We don't see it too often. So either way, if that was your answer, though, just write it in scientific notation and we're all good. Okay. Another one. Example. Find the probability. No, you know what? Find the odds in favor of drawing a red face card from a standard deck. Find the odds in favor of drawing a red face card from a standard deck of cards. This is going to be a two-part question because in order to find out the odds in favor, odds in against, we need to know the chances of successes versus the chances of failures. Actually, you can do this without using probability, but it still kind of gives you the same concept. So odds in favor is chances of successes versus chances of failures. Chances of success versus chances of failures. So successes, how many different ways can you draw a red face card? Well, there's 3 in each suit, right? There's a jack, a queen, and a king. And so if you're only looking at the red suits, that would be diamonds and hearts, of which there are 2. So there are 6 ways to succeed here. And the failures come from all the other options. And so you could either count them up, which would be tedious as all get out, or you could take the total number of options, which is 52, and subtract off the 6 red face cards to give you 46. Yeah, 46. So that would mean that the odds in favor would be 6 to 46. Any questions? Oh, yes, go ahead.
That's how the ratio predicts the chance of success.
Yes, when it's talking about odds in favor, whereas odds against, it'll be failures than successes.
Okay.
But I'll be providing that on the exam, so you don't need to memorize that. But that's how it works. It's always like based on which one's being asked, the failures or the successes comes first. Yes, Ed?
You don't count uses as a face card.
I mean, I guess they could, and I'll be sure to put that like you can ask that question, by the way, during the exam. You can say, is a face card in your opinion is a ace face card? It doesn't have a face.
Yeah, but it also doesn't have.
It's true. So that would be like that's up for debate. I will be like I will be more lenient on that situation if I put that question. Cool. All right. Any other questions on this? One more that I can think of that I wanted to do, and then we'll do a unit conversion problem. A prize machine has 14 blue capsules, 20 yellow, 15 red, and 50 green. With, let's see here, $20, $5, $10, and $1 inside, respectively. In case you haven't heard that terminology before, when you say respectively, that means that in the same order, that's what the sizes have. So the 14 blues all have $20 in them. The 20 yellows, they all have $5. The 15 reds all have $10, and the 50 greens all have $1. The machine costs $8 to operate. What is the expected value? What is the EV? So this is a twofold problem because it's going to make us, not only is it going to make us do probability questions, but it's also going to make us do an expected value. So I like this problem for that reason. So the probabilities are all not found out yet. The thing is, what is the probability that you get a blue? It's 14, but 14 over what? How would you find the over, like the denominator? By adding them together. That was what you're gonna say? Yeah. So exactly. Solution. Total outcomes equals 14 plus 20 plus 15 plus 50, which is 99. Wow, nice. randomly getting 99. That's cool. So the EV, I'm going to skip making the chart and just write each probability multiplied by its result. So if you pull a blue capsule, that's going to be a 14 out of 99 chance. And the net result there would be $12 total. Costs $8 to operate the machine, and then you got a blue, which gives you $20, meaning a net of $12. Now, granted, as I told you before, you can definitely wait until the very, very end to subtract the 8. So you can find all of them by just what you get inside, the expected value of getting something, and then subtract off the $8 at the very end. But it doesn't matter. I'm going to do it as it goes along. Plus 20 over 99 times negative $3. Because if you draw a yellow, you gain $5, but that means you're out 3. Then 15 times 2. So 15 over 99 times a net positive of $2 plus 50 over 99. That's the chances you'll get a green times negative $7. Any questions on the setup there? We'll plug that into our calculators. 20, 3, 15 over 99 times 2 plus 50 over 99 times negative 7. And I get, at the end of the day, I get negative 2.14 if I round to the nearest cents. So this is not a fair game. A fair game, by the way, as a reminder, a fair game means that the expected value will be 0. So this one is rigged, quote unquote, in the machine's favor. The machine is expected to win $2.14 each time it's played on average. Sometimes it'll lose 23 times. Sometimes it will only lose $1 for like 5 times in a row, meaning that eventually it averages out to about $2.14 each time. Okay. That's kind of most topics for the exam.
Question. What was about the word?
Okay.
So I got one of these questions because it said that I had to subtract, like, for example, like the blue 14, I had to subtract that from the total of the dog from the total.
Okay. Interesting. Let me look for that one. Let me pause the recording and look for that. Okay. So 4.3. Okay. Find that. 4.3. Review. Let me know if you see it. This one. Okay, number 6. Gotcha. Okay. So I'm gonna switch over for just a quick second. Just let me write it down. And 14 blue. Probability against, or odds against, odds against. Okay, if one ball is randomly drawn from the bag, what are the odds against the blue ball being drawn? Okay, so let me go ahead and start the recording again if I haven't, right? Nope, I'm still recording. I hate myself. Okay, so let's go ahead and stop share, switch to sharing here. Thank you for your patience, everybody. Okie and that should fix it. And I didn't pause it, right? I did not pause it. Nope, it is still recording. Cool. Cool. So the question was 10 green, there are 10 red balls, 6 green balls, 15 orange balls, and 14 orange and 14 blue balls. And you're trying to find the, it wasn't probability, it was saying the odds against. So the whole thing, so we could find the probability as well if we wanted to, but the more common thing would be we just need to know the chances of success and the chances of failure. And this one's kind of weird because it's a double negative. It's the odds against drawing a blue ball, or the odds against not drawing a blue ball. So you would fail then, like in terms of ignoring the odds against right now. What is the probability of, like, what would be the success? It would be not drawing a blue ball. A failure would be drawing the blue ball, correct? So the failures will be 14 because that's how you would fail this contest, would be if you drew a blue ball. So the successes would be all the other options besides the blue ball. So that would be 10 plus 6 plus 15 and not minus the 14 because we're already taking care of that in the failures. But we could add it 14 and then subtract 14, but that would be unnecessary. So this would be 31, right? 10 plus 15 plus 6 should be 31. Yes. So since it's saying odds against the blue ball, that means we put failures, then successes. Odds against, you put failures first, then successes. So the answer should be 14 to 31. Is that okay? Okay. Excellent question. All right. And so I'd like to do one of the unit conversion problems. Example, let's say, um, trying to think of a good one. A Twitch streamer, trying to be with the kids, a Twitch streamer is performing a 100% speed run of Skyrim without stopping. So this is a very niche area of knowledge in case anybody knows. Skyrim is a massive game. If you've never played it before, you could probably play that game for about 400 hours and still not finish it. It's a crazy long game. But so he's trying to, he or she or they are trying to perform a 100% speed run, which by my quantification is you have to do every single side quest. It's going to take 320.2 hours. if on average they get $1.83 per hour. Wait, no. I'm gonna change that. Not $1.83. On average, they get $175 a day in donations. What like how much will they make? I guess that'll be fine. This speed run. So, like usual, because multiplication is commutative, you can start with unit fractions if you want to, or you can start with the thing that's not a unit fraction. Here, that would be the 320.2 hours. That thing that isn't a unit fraction. However, you could consider it a unit fraction. You could say it's 320 hours, or 320.2 hours for every one speed run. You could make it into a unit fraction if you wanted to, but I'm just going to keep it as 320.2. Solution, 320.2 hours. And so I'm going to make a unit fraction bar. And so I want to find out at the end of the day, I want to know how much money they will make. And so the only other thing that's given is that it is set $175 per day. So we have a couple different things that we could do. We could convert the $175 per day into dollars per hour if we wanted to. So we convert the days to hours, or we can convert our hours that were given to days. It doesn't matter which one you do. Both are valid. I'm going to switch this to hours, to days, but just know you can do it in the reverse order as well. So there are 24 hours in one day, and that would cancel the hours. And so now we have how many days it will take for this streamer to perform the speed run. And then we're saying they get an average of $175 per day. So I want the days to cancel. So I'll put the days in the denominator. It's for every one day, the streamer is making $175. That would mean that the days would cancel, and all we'd be left with is money, which is exactly what we want. Each time I add on a unit fraction, I'm asking myself, what are the units left? And if it's the right units, in this case, we're trying to find how much money, and we have gotten to just money, I'm done. So I just need to do 320.2 times 175 and then divide that by 24 to get that the Twitch streamer will make $2,334.79 approximately. Any questions on that? Those are the more fun unit conversions. I think so remember the final quiz is not written by me. It's a departmental thing, and I don't think they're nearly as cool as I am when it comes to unit conversion problems. So it's probably going to be something lame and not fun, like converting from centimeters to inches or some stupid thing. But we can't all be awesome, right? We can't all be that humble and that awesome at the same time, right? So, any questions on this, or do we want to see anything else? So I'm pretty sure we've kind of covered everything that's needed for the unit 4. We didn't do a combination problem, but it's kind of the same concept. We did a fundamental counting principle problem. We did a permutation. We did a probability. We did an expected value. Yeah, we're pretty good. Unless there's anything else that people want to do. All right. That'll do it for today. If you have any questions, feel free to email me. Hopefully, I don't see you tomorrow. Or not tomorrow. I definitely won't see you tomorrow, but hopefully I don't see you on Wednesday. I want you guys to have a good break, but please keep focused, and I will see you guys that next time.